Welcome to K6 Wellness Revolution, where we believe health is worth fighting for. This podcast focuses on all things related to natural health, wellness, and vibrant living. We know your time is valuable, and I'm honored that you're spending some of it here. So get ready, because the Wellness Revolution starts right now. Welcome back to the K6 Wellness Revolution podcast. I'm Sharon, traditional naturopath and family nurse practitioner, owner of K6 Wellness Center, where we blend trusted expertise, compassionate care, and a passion for helping you achieve optimal health. Because wellness isn't just a goal, it's a revolution. Today, I'm joined by Dr. Mark Tommerdahl, a neuroscientist, engineer, and internationally recognized expert in brain function assessment. Dr. Tommerdahl earned his PhD in biomedical engineering and mathematics from the University of North Carolina and spent more than 25 years as a professor of biomedical engineering at UNC, where his NIH-funded research focused on understanding how different regions of the brain communicate and adapt. His groundbreaking work on cortical dynamics and sensory processing led to the development of the technology behind the brain gauge, a non-invasive assessment tool that measures brain health and function through sensory testing. Dr. Tommerdahl has authored more than 150 peer-reviewed publications and continues to collaborate with researchers worldwide on topics ranging from traumatic brain injury and neurodegenerative disease to pain and cognitive performance. And today, we're going to be discussing the science behind the cortical metrics brain gauge, how it works, what it can tell us about brain health, cognitive function, and neurological performance. And a fundamental question many people have is, can we objectively measure brain health as easily as we measure things like blood pressure or heart rate? So, Dr. Tommerdahl, first of all, thank you for joining me today.
Oh, thanks for having me.
And I guess my first question is, what problem were you trying to solve when you developed the brain gauge?
Well, one of the things that we did for the first 20 plus years in the neurophysiology lab, that we were trying to understand how the brain worked and and we had a lot of ideas about interactions within the brain, between different areas of the brain and basic connectivity in the brain. So functional connectivity is something that we were studying in an animal model. Animal model means we were doing laboratory experiments in the animal, and we were trying to understand what it means for different parts of the brain to be connected, or cells, and how cells communicate. Well, or how neurons communicate. And basically, there were some very fundamental and very robust things that happened dynamically in the brain over and over and over again, as long as nothing went wrong. And after doing a whole bunch of animal experiments, we started saying, there's an easier way to study humans and to do sensory testing in humans that would parallel what we do in the lab. So in other words, we were looking at patterns of brain activity in the animal, and we wanted to see, well, how does this correlate to what a human would experience, what an individual would experience if we delivered the same type of vibration. So what we did was we deliver vibration to the skin of an animal, look at the activity pattern in the animal, and then we deliver vibrations on the skin of human subjects, and we'd ask really simple questions. Which stimulus is bigger, for example? We would deliver two stimuli and say, which is bigger? And it turned out that the measures and the objective measures we developed for individuals correlated like 98, 99% to what we were seeing in brain activity patterns. So here we had a way to probe brain function, doing something very non-invasive just by vibrating the fingertips. So we can vibrate the fingertips and ask simple questions, and it correlates very well with what's going on in the brain. And that seems like a silly question, but for many, many years, sensory testing in the tactile world, or on the skin, focused primarily on skin sensations, and people were mostly focused on skin physiology, and they would deliver very tiny stimuli that didn't have very good signal to noise ratio. And if you applied engineering principles to the physiology, it's very simple was very it was very straightforward for us to make the leap and start delivering things. And so the brain gauge is this little device, handheld device that looks like a computer mouse, and we call it a lab in a mouse because we deliver stimuli to the fingertips. And then we ask questions about what you feel, and we
And
can get very
so,
objective
and
measures with it.
And so you're giving an assessment that is more objective and it's quantitative and
Mhm.
it's an accessible measure of brain function instead of something that's just purely based on symptoms or something that's
Right.
a more subjective assessment. And but okay, so and it is interesting because when I did it for the first time, and it didn't hit me till I was giving it, you say, now that's not the mouse because it does look like a computer mouse with two buttons, one
Mhm.
for your index finger and one for your middle finger. Why does it look like a computer mouse?
Well, it didn't always. I mean, the very first version weighed about 100 pounds.
Oh,
And
wow.
so, and it was huge. And, because that was the type, it's very hard to deliver very high fidelity or very highly accurate stimuli to the skin. But that's what we had in the lab. We had something that was enormous. And like I said, it weighed 100 pounds and it was attached to, like a dental, a dental stand. And it
Oh,
was with a big armature on it, and had to focus it, everything. But what we did was, we when we got the very first results that I mentioned that we got very good correlation, we said, well, that's really good. And then we started doing some other studies on, and the first cohort that or first group population that we looked at was autism. And when we
mhm.
started studying autism, we found enormous differences based on, and the design of the experiment in that case, or the design of the study, was based on postmortem histology that had been studied in autism. And so we got a really large difference between. I'm going to get to the point why it looks like a mouse in a minute, I promise. I know I drift, but that's the problem. History is important.
Okay.
And
I
so it was a
trust.
very large stimulator. And but once we got good data on autism, we applied for funding in the autism space and got significant funding to build the world's first portable tactile stimulator. So the world's first portable tactile stimulator actually weighed about 15 to 20 pounds. So we shrank it a lot,
Mhm.
and we said, well, but then we started doing a lot of different studies in a lot of different areas because a lot of people started collaborating with us in things like pain and autism, ADHD, uh, Tourette's, OCD, uh, and then trauma. So once we started doing concussion studies, we started getting really good data because we were finding very objective data. And most of the concussions, what most people rely on in concussion is basically a self-report or a questionnaire. And
Yeah.
so the whole idea, so let me address the question of self-report real quickly. Self-report is when your doctor says, "How do you feel?" And you say, "I
Mhm.
feel fine." Well, your brain is a really good tool to evaluate a broken leg. Your brain is not a good tool to evaluate a broken brain. And so it's not an objective measure. And so
Yeah.
what we were trying to do is develop objective measures. And once we had the device down to, 10 pounds, we started talking to the people in the Office of Naval Research, and they had us join what's called their BLAST program. It was an acronym or it is an acronym that stands for just what it sounds like, where you're assessing people who've been, exposed to blast, or and they had concussions. And we did very well there, but they funded us and to build this smaller and smaller. As it got smaller, we experimented with a lot of different shapes and sizes, and it turns out a computer mouse is something that's very easy for. That shape of a computer mouse is there for a reason. It's years of studies and ergonomics, and turns out that's a really easy thing for most people to put their hand on and rest
Mhm.
their hand on, and because our target was to vibrate fingertips. So that's how it ended up very small. So we got
Oh, very
very
good.
generous funding from the Office of Naval Research to keep making it smaller.
So why the sense of touch?
Well, when I first went to UNC as a grad student, I wanted to study how the brain worked, and I was
Mm-hmm.
shopping for a lab. And again, history is important. The person who was going to be my mentor, the very first one I interviewed with him, he said, "Look, what we really want to study is the brain, and we want to understand how the brain is working, how objectively it's a function. We want objective measures of its function." And he was talking about sticking electrodes in the brain and measuring that way. But the somatosensory system, or the sense of touch, is the highest fidelity system. It is the best way to study interactions in the brain, because
Okay.
when you deliver stimuli or vibrations to two fingers, you're activating two places in the brain side by
Mm-hmm.
side. That's really clean. So think about it. Like right now, you have all this ambient environmental noise. You have all this light around you going to the visual cortex, going to your visual system. You have sound going to your auditory system, constantly pinging. Those systems are bombarded all day long. Your somatosensory system, on the other hand, is a nice, quiet lab. And when you deliver two fairly strong stimuli, you feel them. And that's the main thing. And that's a very clean, high fidelity stimulus that you get in that part of the brain. That's one reason.
Mm-hmm.
But it's the best way to study and it's the best way to study the brain. He said, and what he told me was at the time, he said, look, everybody's known this. It's just really hard to do, because to study vision, you just need a flashlight. To study auditory system, you just need speakers. But somatosensory system is well located. It's right in the middle of the brain and the parietal lobe, just right here.
Mm-hmm.
And it's really the best way to study what's going on in the brain. And it's got access to everything. Everything's connected. But because you can deliver such clean signals, you can get very objective data.
Mm. And why do you choose the fingertips over some other area of the body?
Well, the fingertips are, the very first, the very first device we built. We kind of sat back and geeked out and said, "What should we study? Where should we do it?" And we actually studied the back of the hand. And the back of the hand has no use dependent plasticity. In other words, you don't
Oh,
tie your shoes with the back of your hand. You don't do
true.
anything with your back of the hand. And we got fantastic data. There was no variability from one subject to the next unless it was a different population. I mean,
Mm.
as long as you're neurotypical and healthy. Well, the problem is it required somebody to stick their hand underneath, underneath something and in something, and that kind of freaked people out. And it made more sense to vibrate the fingertips. That's
Yeah.
one reason. Another reason is your fingertips are highly innervated. And you get the same results with other things. We've actually done amputee studies. We have an amputee model that you can strap onto it. Obviously, if you don't have a hand, you can strap it onto your arm or your leg or
Okay.
wherever. It's just got to do with innervation density and a few other things.
Okay. That's interesting. So when you do this, I guess this question was actually posed to me, and I thought it was interesting, and it brought up something you had mentioned to me when we talked the first time. But it's, I guess it's the question of, are you, and it goes. I guess we'll talk about it a little later. But are you really measuring the brain itself, or are you testing somebody's ability to take a test, just like when you're training the brain? I mean, I know the answer to this question, but
Yeah.
when you're training the brain, or you're doing like the brain gym things
Mhm.
and some of these online trainings,
Sure.
or brain exercises, are you just learning to game a game, or are you actually
Right.
addressing those building blocks, and how do you tell the difference?
Right. So what we do is we target what we call functional or fundamental building blocks of brain function.
Yeah.
And that's what's really important. And what you're doing is, because we're delivering stimuli to the fingers, we're going straight to these fundamental building blocks and targeting those things either with testing or training. And it bypasses language. It's not language. It's not a language dependent test.
Mhm.
It's not in the cognition or executive space. All these little brain games and puzzles. Yeah, you can
Mhm.
sort of learn different things and little tricks to play them. It's sort of,
Yeah.
and that's the problem is it's really hard to drill down to those fundamental building blocks unless you deliver very clean, very high fidelity stimuli and just ask a really simple question like which one's bigger, and you can target things like lateral inhibition or things like that, but which are fundamental mechanisms. And when you so one thing to do is put this in the physical analog. And when you talk about brain fitness, or brain measures, you can also think in terms of physical fitness. And the question I get this question all the time. It's similar. And so if somebody goes out and they go to the gym and they start lifting weights, they get stronger. And so if you test them by saying, okay, how much weight can you lift? Well, that's a fundamental feature of physical attribute or physical strength is how much they can lift or how many pull-ups they can do. And you can actually measure that. And even though they're training by doing that, they are getting stronger. And that's very similar to the kind of exercises we do because we're targeting those basic fundamental building blocks. So
Yeah. And so let's talk about the 8 core metrics that the brain gauge measures.
yeah. So
It
we actually measure a lot more in research world, but the ones that are listed
Yes.
as we measure, we measure things like speed, focus, accuracy, timing or timing perception, how well you can, sense of order, plasticity, but and then we have an overall metric that combines everything. But let's go one at a time. So if you're doing a physical analog, let me go back to my physical attributes. And basically, if you think about physical fitness, what do you really need to be physically fit for, say, for a particular sport like swimming or running? You need to be the best. You need strength, endurance, and flexibility. So strength equates with speed. And
Yes.
that's one of the metrics that we have. Endurance equates with focus or the ability to attend to a stimulus.
Mhm.
Flexibility is plasticity or how well you can adapt to your surroundings. Now, so I mentioned those three as being the physical attributes because I was a competitive swimmer, and swimmers are terrible. They're in great shape, but they're not always the greatest at athletic games, much to the chagrin of some of my teammates in college. We were terrible at intramurals because we had no coordination.
Oh.
Coordination equates with timing, and there's a couple of different timing measures that we have. One one of them is called temporal order judgment, which is just simply what is the order of things, and it really has to do with it's more in a frontal parietal measure, and it's got to do with the question is which came first, but we try to work on your timing just so you can differentiate those. Um, and like people with dyslexia and people with Parkinson's and people with schizophrenia or the worst, people with schizophrenia do very, very poorly at that test, but people do poorly at that test and some people can train and get better. But that's a frontal measure. So if you're
Mhm.
damaged, if you have a mild concussion and just the damage is kind of localized to the front part of your brain, then timing perception might not be thrown off, but TOJ will be. And consequently, if the back of the head gets damaged, or if you turn off uh, a part of the brain called the cerebellum with TMS, you can't do the timing perception task. That's where we ask which of these two vibrations lasted longer. And basically that sounds like a really simple test. And
It
why
is
does that
not.
matter? But it's basically the cerebellum is coordinating everything. And that's the part of the brain that really has a lot to do with this. And if the cerebellum is messed up, then you have to do poorly on that. So those are the different tests that we do, and we look at and we measure different things a little bit differently. Like plasticity is measured by computation between a couple of different measures. Anyway, the plasticity is very dependent on how well you do it. A couple of tests where we just simply ask you which of these two stimuli is larger. And it's got to do with this function in the brain where your brain is always trying to maintain homeostasis between excitation and inhibition, always trying to can maintain that balance.
Hmm.
And your brain is always chattering. Those cells aren't just lying there asleep all the time. They're always chattering. And when something comes in, like a vibration, it gets active, and then one part gets active and another part gets suppressed.
Yeah.
And the extreme case to think about in terms of imbalance between excitation and inhibition is epilepsy. So if somebody doesn't have enough inhibition, excitation takes off. And so obviously the measures that look at that balance of excitation and inhibition, they're very sensitive to that.
Hmm. Yeah. So with plasticity, it's like, is your brain adaptable, and
Mhm.
and can you learn? Like, what's your capacity to learn, I guess. And
Yes.
then just like with speed, like um it was reaction time, and then how
So
fast do you
reaction time
process?
test, reaction time is a really interesting thing. And it's, that's basically what speed is. How fast can you
Yeah.
react to the stimulus? And there's a lot of little online tests that will do it, but they're inaccurate. So we have accuracy of, like I said, this is a lab and a mouse. It's outside the computer. It's outside your phone. And, the other systems, other people that do this with little cute little games or whatever, or online tests, they add between 100 and 400 milliseconds to your time. Your time should be 200, and it should, 200 milliseconds is what everybody should shoot for. And around 600 milliseconds is kind of like, that's getting near dementia. And that's when you need to really work it.
Isn't that where you said you're not supposed to have a driver's license at
Yeah, we take the
600?
car keys away over 600. That's, but if you were to do this on a phone, you wouldn't break 600 because it adds 400 milliseconds just right off
Oh.
the top. And it's variable the way it adds. So you might, so we tested it robotically. We test all these different systems with robotics, just take all the human factor out. And
Mhm.
there's so much variability on things like phones and laptops that you can't, you could take all the data you want and try to make a guesstimate. But if you do the test and then do it again, you're going to have a wildly different answer based on nothing. And we saw that
Mm.
over and over again. But the important thing about having an accurate measure is that we can measure attention in 90 seconds. So we have a focus score that
Yeah.
measures how well you can attend. And so when you're doing a reaction time test, it's called reaction time variability, and you measure it over and over and over. And that's a really, really sensitive test. And it basically gets disrupted anytime anything in the network is disrupted, the network being the brain. So somebody can walk in the room, somebody can do anything. Um, if you have ADHD, you have somebody with ADHD, they're going to have very high numbers and do very poorly. And we say, yeah, if it's over 50 for that, they can't handle heavy machinery. So that's our cutoff for things like that.
And does somebody's reaction time increase with age?
Yeah, increase being getting worse, but
Yes.
yes and no. It does not increase with healthy aging. And that's a
Okay.
really good question.
Thank you
Yeah.
for defining that.
Yeah. With healthy aging, it does not increase. And there were some studies that were really interesting. We didn't do them. And I'm just citing papers or other work where really interesting. If you look, and it also parallels what we see in clinics. But if you look at the difference between an active 20-year-old and a sedentary 20-year-old, there's no difference. There's very little difference, hardly any
Mhm.
difference at all. If you look at a 60-year-old who's active, who's say maybe runs every day, works out, versus a sedentary 60-year-old, there's a huge difference. Somebody who's inactive and they've aged a lot. But you can, and as we get older, we have to work out more. That's both true. That's another parallel between physical fitness and brain fitness. Sorry to
Yeah.
say it, but when you're in your 60s, it's time to start working out. So, or more, work out
Yes.
more, and unfortunately we all want to just take a nap. That's as we get older and older, everybody wants to just take the easy way and say, I'm just old. I'm going to have bad scores. And, we've had people try to tell us that, no, my score is going to be bad because I'm old. No, I've seen 80-year-olds with perfect scores, and that's awesome. They might not start that
Mm,
way, but they get there. And that's really
right.
cool.
Yeah, that's awesome. And then let's see. So, of all of these metrics, which ones tend to change first when brain function starts to decline?
Well, again, reaction time is a really good one to pick on. And
Yeah,
I consider it a little bit like blood pressure. It's non-specific. And
yeah.
the other measures are a little bit more about the why. And so if you're like, what I suggest to clinics is, bring, when the patient walks in, do the heart rate, blood pressure, and the bring age quick check, which gets reaction time. And that's a pretty good overall indicator. It won't tell you what the problem is. But the other measures, they dive a little bit deeper into specifics of what's going on, whether it's cerebellar parietal or temporal or frontal parietal, or whether it's GABA mediated or whatever. You can sort of do a deeper dive and figure out what the problem is, or you can just follow the measure and see which ones get better. And different ones, we have a better handle on things like TBI, like when somebody gets concussion, because we only have to track somebody for 3 weeks to know, different scores get better at different rates and different scores get worse at different rates. So on day one score will get worse, but then on day 3 through 5, when you have more neuroinflammation, other scores get worse. And the
Mm-hmm.
recovery and refractory period is very different for the different scores because they all target different things. So
Yeah,
with healthy aging or unhealthy aging, you have to track a lot longer. So to see
yeah,
where that is.
yeah. So, what kind of things can alter your reaction time from day to day besides besides overtraining your brain?
Well, I don't know. I haven't seen anybody overtrain yet, but there'll be a first time, I'm sure. Um, I did have, we do have brain training in a brain gauge gym. And I
Yeah?
will just mention, you don't want to just train all day. I had a mother call me
No.
at the time and she said, my son trained all day long and he didn't get any better. And I said, you just had him go to the weight room all day long and then ask him to lift more weight. It's the same thing. You're doing this for your brain. So what
Yeah.
kinds of things? So, well, what slows people down or improve? You want to know what improves it or makes it worse? Pretty much any disruption to the brain function will slow reaction time down. But on a day-to-day basis, things like sleep deprivation is one.
Mhm.
Let's say medications, that's another one. So, and this is even if it's something like cough syrup, we're not talking about really heavy stuff. We're talking anything will disrupt brain function. Uh,
Therefore, alcohol also.
well, not just alcohol, but drinking behavior. So, yeah, if you drink and you say, and then you test, then I'm doing, it's gonna have an impact. But
Yeah.
one of the studies that we did was on 18 to 22-year-olds, and we recorded their drinking behavior and found that people who drank in that age group who drank more than 60 drinks per month, say whether they did 2 beers a day every day or 15 beers on the weekend or 15 drinks on the weekend every weekend, they drink more than 60 drinks per month, then their plasticity score was really impacted. So their ability to learn. So not a good thing to do in college is drink that much, but people
For
do it.
sure.
Yeah. And so anyway, but we're testing these people fully sober, fully with BAC of 0. And what we're looking at is just what was their behavior. Might be
Mhm.
days before, might have been days since they'd had a drink, but it will impact them. Any kind of recreational drugs will impact you know, any
Yeah.
kind of medication, pharmaceutical, just about anything.
So, likewise, maybe like exercise or meditation then would
It does. So going back to our
improve.
sedentary model, sedentary versus active. So when we were looking at in our we were looking at 20 to 22-year-olds who are sedentary versus active. I mentioned there's very little difference in reaction time.
Mhm.
But when those same individuals are part of a study where they say, what's the impact of exercise? The people who ran every day for, say, 3 miles a day or more, and then ran 30 minutes, and then tested improved their scores. Their scores were better after that little 30-minute run.
Wow.
The people who were sedentary and not used to running, they'd go out and run, and then their scores were terrible. So so that does reflect a little bit of difference, when you're
That
sedentary.
exhaustion versus endorphins.
Exhaustion versus endorphins, exactly. You get the endorphin high after about 30 minutes, and it's real. It really does
Yeah.
impact. Whereas if you're a non-practitioner of the art of exercise, it's
It's
going to
just
hurt.
pure exhaustion.
It's going to hurt. You're oxygen deprived.
It's the kid who did the brain gym all day long.
That's right. I mean, yeah, I'm not promoting the brain gauge gym as a substitute for physical exercise.
No, no. No, for sure. What if the reason you're so tired isn't just because you're busy? If you're dealing with low energy, brain fog, inflammation, or hormone changes, it might be time to try something different at K6 Wellness Center. At K6, we offer advanced wellness therapies like nutritional IV treatments, hormone optimization, regenerative medicine, plus extensive testing and health screenings you just won't find in traditional medical clinics. That means deeper insight into what's going on in your body and a plan designed just for you. So if you're ready to stop pushing through, just trying to survive the day and start living your very best life feeling healthy and strong, visit us at k6wellness.com to set up a free discovery call or call 214-352-7546. No matter where you are in the world, K6 Wellness Center can help you on your journey to great health. And then I guess like stress too, right? Your stress level, if you have a bad week of
Sure,
stress,
stress,
then
and some measures are more impacted by stress and anxiety than others. And
yeah.
one thing that the brain gauge does, if 20 minutes of use of the brain gauge actually improves, um, calms you down. And that paper's not out yet, but based on heart rate variability, it does
Oh,
tend to calm you down after using it for 20 minutes. So I find that fascinating, but there's a
that
reason
is,
for that. And that's another reason the sense of touch or somatosensory is a really good measure or really good way to do brain training. And if you think about it, what are the
yeah.
majority of people doing now? Where is all the activity? What part of the brain is all the activity when you're when you're playing games or when you're on your phone or whatever? Well, it's not in somatosensory cortex. But every time you activate one part of the brain significantly, it's going to inactivate another part. And if you activate parietal lobe, it's going to suppress the frontal lobe, where that's where your anxiety is. And so that just makes
Mm.
a lot of sense. And playing phone games, it's not helping your anxiety.
Yeah. That's interesting. And it also I've noticed, as I pulled the brain gauge out and I've had everybody doing it, nobody wants to stop, and you
Right.
say, "Okay, you
Yeah.
somebody else's
Yeah,
turn."
we were at a meeting
Everybody
and
wants
yeah, exactly.
Yeah,
That's why,
everybody wants to keep doing it. They're like, "Wait, I'm gonna do another one. I'm gonna do another one."
yeah,
It's
that's what we see. And then like we had a couple of kids come in at the end of one of the meetings we were at, and they started doing it and they didn't want to leave. You're like, no, I want to do more. And so, but one of the kids was apparently he had some anxiety issues, but you could tell he was calming down, except when his dad drug him off and said, no, we can't stay. So
So, can brain gauge detect subtle changes before symptoms appear? In
I think so. I mean, like I said, for the last 150 years, if you look at the literature closely, you'll see that like something like reaction time has stayed solid at 200 milliseconds. Now, there's a lot of bad data out there. Like I mentioned, if people using cell phones and laptop, those kind of things,
Mhm.
there's been a lot of drift in the last 30 to 40 years since 1970 because people got sloppy about the way they did their science. But if you look at all those papers that use calibrated lab equipment like the brain gauge, it stayed solid at 200 milliseconds. The reason I'm bringing this up, and I said the number we mentioned for dementia is around 600. But if you're drifting from between 200 to 300 to 400, it's time to turn things around. And so
Yeah.
the way to think about all the scores is like when you take your scores and you say, okay, can look at all these different papers. We got tons of papers out there looking at different scores being worse for different conditions. And so the question is, well, if you let's do our physical analog again. If a particular condition means that this person's weak, or they're say they can't lift weight very well, then we have them do exercise to get it better and strengthen the connectivity that's required to improve. And so if you improve, so the hypothetical question here is that if you work out and do the brain gauge gym or whatever you can, whatever intervention you can to get your scores back down to normal, back down to
Hmm.
what they should be, the hypothetical question is, and since we've never seen anyone with dementia with a reaction time less than 400, probably less than 500, I'm being generous, over all the published literature, you say, well, as long as I keep my scores normal, does that mean I won't have dementia? Well, the hypothetical question is probably not, or that's the question we're asking. And so
Yeah.
far, when people reverse and do the exercises to get their scores better, we're seeing a big reversal. And they do different interventions. They do ozone therapy. They do electroceuticals, all kinds of things, and complement it and track it with a brain gauge. And you see people getting better. And so the best thing to do is catch your scores before they get worse. Know
Right.
what you're doing, and then it's much easier to take somebody from who's not at the dementia level and turn them around and get them back down on track than it is to take somebody who's gotten a little bit far.
I think that's true because I think too, just in our culture, we're looking for big changes and we want something fast and we want something really big. And then sometimes we're not tuned into the subtle or we're so distracted,
Right.
which is a problem
Right.
also, right? With brain
Right.
health. We're so distracted and we live in such a distracted state. But we can, through the use of this type of technology and this type of training, start to monitor responses to diet changes, which is a
Mhm.
big part of improving neurological health. Or I wonder if this supplement regimen is working, or this exercise program, or this change in my sleep, or my heart
Right.
rate variability during sleep. We should be able to see these improvements then,
Right.
and
Right.
right.
You
Yeah.
should. You should be able to see improvements and one thing we find is when people start using the brain gauge frequently, they start getting more in tune with their scores, more in tune with all the things in their life that are impacting their scores, and sort of gets them turned around from drifting. So, I mean, I've always called dementia sort of the boiling frog syndrome. You put a
Yeah.
frog in a pot of water, cold water, it'll just sit there and you turn up the heat slow enough, it'll boil it. You can boil it. And dementia is the same way. From one day to the next, you don't see the drift that you mentioned, but you don't see the, but if you're measuring and if you're training, you'll notice the drift. And the other thing
Yeah.
about you mentioned supplements is a lot of people just take supplements. They don't look at the impact. They don't have recommended dosages. Um, and they just, you need to say, well, how much is too much?
Yeah.
Everything, you know, everything, even if it's good for you, has a tuning curve. So,
Mhm.
caffeine's a real good example. So I'm sure anybody that's taken too much caffeine knows that their scores aren't going to be good if they take too much. And a lot of my students used to test themselves. I always handed out brain gauges to all my students to do their labs, but they would do their own little projects themselves. And every year somebody would say, "Yeah, I could see the effect of caffeine in the morning,
A
but if I
double
took
shot
too much,
versus a quad shot.
oh yeah, taking a couple of shots of espresso, man, I scored really good. I took a few more shots and I crashed." And I was like, "Yep." So
Yeah.
that works that way.
Yeah. Oh my goodness. Yeah. Well, I think too, that shows the importance of trends just with in the age we are of biohacking,
Right.
trends are important and longitudinal tracking because it does reveal trends that maybe just aren't obvious
Yeah.
to
It's
people.
hard to find things that are going to be a quick fix. And again,
Yeah,
brain fitness parallels physical fitness. If you start working out, it's going to take you 3 weeks to see an effect, 2 to 3 weeks to see an
at
effect,
least,
whether
at
it's
least.
physical or. And so I kind of recommend people when they get started with a brain gauge, sort of start easy and work your way up and treat it like
Mhm.
a couch to 5K program. All these couch to 5K programs where people are sedentary and they start off walking 2 days a week. Then they get to where they can walk/run 2 or 3 days a week. And then they get to where they can run a 5K over time. They don't
Yeah,
do it overnight by taking a pill. It's just
yeah,
that's getting in shape.
yeah. So I have a few questions just about clinical applications
Yep.
of brain gauge, related to concussion and traumatic brain injury.
Okay.
How is brain gauge used? I mean, I assume you wouldn't. Do you use baseline testing with that? Because really, your baseline is going to
No,
be
we
pretty
don't. Yeah.
low.
We're probably one of the few, if only, measures that people use to track recovery from concussion. We don't require a baseline measure. And one of the reasons that we don't is because we can take two measures and look at the difference between them and tell and extract information about what's going on. And we don't have, and baseline measures, well, let's go down this path. Baseline measures are terrible because let's say, an athlete, student athletes they go to college their freshman year, they do a baseline measure, and then they don't get a concussion until their junior year. That's sort of saying, oh, there's really no going to be no cognitive or cerebellar changes or any kind of cortical changes over the next 3 years, between 18 and 21. And we all
Yeah.
know there's going to be a lot of changes over the
Yeah.
years. So the
A
best thing
lot's
to
gonna
do is
happen.
just track them back. And, I basically, there's some tests that are very sensitive to recovery that we have.
Mhm.
And we don't need to, and you don't really need to, we just don't need a baseline. And
Yeah.
we do very well in tracking people that are recovering from concussion.
Yeah. Yeah. Are there any studies or, um, any published papers showing any, expected, outcomes with improvements or time? Is there I mean, it's so hard, I don't know how you would do it,
Well,
but
there's a lot of studies that the majority of the studies are on assessments. So looking at somebody with concussion versus healthy control, somebody with autism versus neurotypical. So,
Mhm.
and those are all in like developmental space or degenerative space or trauma space or pain. So those are all those studies that are looking at what are the differences for people, say with migraine versus people without. And,
Yeah.
and so, but the studies coming out are case studies now, just looking at, because it's really hard to do studies looking at patients when you do something other than case studies. And the reason is no two people are alike.
Yeah.
Everybody's different age, everybody's got a different problem, everybody's got different issues. And so we measure their initial conditions, we are tracking, how they do in response to different interventions, and every clinic is doing something differently. So
Mhm.
basically you look at it at every clinic, every individual is effectively a research subject, but they're a research subject of an N of one where the goal is to try to get them better. And I think the problem with a lot of large scale studies that we don't want to be a part of are where they try to make everybody look the same. And they say, okay, we're going to do this study, but we're not going to treat them. We're just going to track them. And like, yeah, I don't want to do that. I want these people to get better. So
Yeah.
that's why it's really, we're going a different route. It's
Yeah.
complicated,
Yeah.
but we're,
Well, and as a person who's had half a dozen concussions, I mean, no two concussions were the same, you
that's
know?
right.
And
That's
so your recovery is definitely different each time as
yes.
well. So it
Most
does make it
most clinicians will tell you if you've seen one concussion, you've seen one concussion.
Yes,
And that's
that's
it. They're
exactly
all
right.
different. And so
Yeah,
it's kind of silly just to clump everybody, but
you
it's actually
can't
true.
do it.
Every single thing we have is a spectrum. I mean,
Yeah.
whether it's pain, neurodegenerative, everybody, like take somebody who's got early dementia. Well, that early dementia could be caused by playing rugby or football without a helmet when they're growing up or something,
Yeah.
or just getting a lot of concussions, or it could be genetic, or it could be from repeated hypoxic bouts. You don't
Mhm.
know, or it could be from drug abuse from early on. So everybody's different, or it could be a combination of everything. But you just
Yeah.
don't know what the cause is until you've done all the studies.
Yeah. So, with cognitive decline and dementia, we have like the MoCA and, there's all these different, cognitive assessments. Could this become part of routine brain health screening?
I think so. I mean, it's pretty straightforward. It's pretty easy.
Yeah.
And the thing is, when you think about all the assessment studies that we've done and the goal, and you realize, well, the goal is to get people that have poor scores that fit the framework of having cognitive decline or dementia, is to get their scores to look like neurotypical or healthy controls, and in
Mhm.
any way that you can. And so whether it's brain training or a different kind of intervention, it doesn't matter as long as you can get them there. So,
Yeah. How about with ADHD, using the brain gym? I would think the focus,
mhm.
shows pretty significant improvement. Do you have any
Yeah.
comments on
So
that?
the brain gauge has is so one there's several clinicians now using the brain gauge gym to work with adolescents with ADHD.
Mhm.
And one of the first ones to do this contacted me one day and told me, what do you see with the brain gauge gym and adolescents with ADHD and adults with memory loss? And I said, well, when we see people it seems like when they do the brain gauge gym along with treatments X, Y, and Z, they get better. And she said, oh, we're seeing the same thing. I said, what are you doing? And besides the brain gauge, oh, we're just do the brain gauge gym. I said, that's interesting. So, and then, so she was just doing they're just doing the brain gauge gym for working with adolescents with attention problems. And about a month later, she contacted me again. She said, okay. And so the brain gauge had, on the basics level, it had 15 levels of exercises, and it went therapeutic through basics to basics plus. And she said, okay, so I've got this 13-year-old and she had attention deficits, but now she needs something else. I said, what do you mean? She said, well, she's finished basics plus. She's gone through all 15 levels of the training. And I said, how's her attention? Oh, her attention's fine, but she just wants more. I was like, okay. So we built the elite. So now it goes from therapeutic up through elite because
Wow.
this person got so good and she was getting like, I need something harder. I was like, okay. So you do get better. It takes time to progress through, but she got better and her attention got better. So it's really, really interesting. So,
Yeah. That's awesome. That's great. Okay, how about chronic pain? How does chronic pain alter, sensory processing in the brain?
so I'm glad you asked. This is another reason for studying the sense of touch.
Yeah.
Because as you know, there are no pain receptors in the visual system. There's no pain receptors in hearing. You might hear something you don't like or see something you don't like, but those aren't pain receptors. All
Mhm.
pain receptors go through somatosensory, through the sense of touch. And
Mhm.
so there's different areas in the brain, and one area lights up really bright whenever there's pain coming in. You get a pain receptor. Chronic pain is kind of stays hyperactive. And when the area right next to it is the area where vibrations activate. So they're like the vibrations that we send through the sense of touch, um, through the brain gauge. But there were some studies back in 2012, 2013, where people showed that if you do sensory testing on the skin, or like this is what the brain gauge does, it actually improves pain or chronic pain more than just delivering high frequency vibrations to the skin. Some people have seen alleviation with pain by delivering vibration to the skin in different places. And that's because of this yin and yang between excitation and inhibition that goes on in the brain all the time. When you have chronic pain, this particular pain area, it's super hyperactive, but the area next door is getting suppressed. And because it's suppressed, people with pain don't do as well on specific tests. So if pain, just think in terms of pain activation being really high, and then, okay, and it's going to suppress and make, normally these two areas are side by side and they're like this. They're very much the same in terms of just chattering. But when you get a lot of pain here, then the other area gets driven down. And when that area gets driven down, it can't, it can't perform on the testing as well. But more testing will drive that area up and sort of hold the pain down. So one way to remember this, whether it's true or not, if you touch something that's hot, you're immediately, like, you touch something and you go, oh, that's hot, that's going to hurt. And you immediately start rubbing your fingers. So you're delivering mechanical input to your fingers, through your fingers, and that is it's not what's on the skin. It's that you're delivering mechanical input there to suppress the pain. So anyway, that's sort of like I mentioned, the yin and yang of pain and touch.
Yes. Yes. Okay. So how about neurodegenerative disorders like Parkinson's, right? So you're dealing with a tremor at rest, but then usually with intentional movement, there's better control. And I did watch, a client with Parkinson's do brain gauge, do the assessment, and it was pretty good. And but obviously there was some speed issues, and the TOJ I think the TOJ was problematic.
Right.
What do you find?
That's what we find in Parkinson's, is that TOJ and timing perception is problematic. And, we've had people with milder tremors who had Parkinson's in their family do the brain gauge shim and have their tremors go away. I mean, in no way are we making any claims to cure, diagnose, or treat anything with the brain gauge, but it's just interesting that exercising and getting faster will help things. So one thing that you notice in all these neurodegenerative problems is speed is an issue, that they're poor on speed. Well, it's not just that it's reaction time. So the exercises that we're doing, if you do just a speed drill, you'll get a little faster. You do all the exercises and cross train, you'll get a lot faster. And that's because those exercises are targeting organizing different parts of the brain and getting them organized and working together. And that's actually more important to speed than just speed drill. So a lot of, think of Parkinson's as being where cortical ensembles are not organized as well, and they're not talking to each other as well. So one reason things aren't coordinated is because the brain's not fast enough. And so when you improve speed, when you improve timing, then that might lead to improvements in overall performance. So
right. And so I would assume you would say the same thing about any age-related cognitive decline. Same thing.
I would.
Cross-train, and it's going to improve across the board. Yeah. Okay, so I want to go back real quick because you'd mentioned the cortical metric score, which was kind of
it's an overall score.
Yeah, is that like the credit score for your brain health?
Yeah, it's just credit score for your brain. I like that. Yeah, I've not heard that before, but sure.
Well, I don't know.
Yeah, why not? Sure.
Is that how we should
people
interpret
track
it?
is the overall cortical metric, even though you can track individual scores, but the cortical metric is the overall score that you want to sort of take a look at every once in a while.
Okay. Okay. So where do you see brain health monitoring heading over the next decade? Because Alzheimer's is just, it's exploding. I think they say 117% increase year over year in the number of cases.
I think the only way to turn things around is to get everybody, well, everybody to take it, take advantage of the fact that they can take control of their own brain health. I mean, the whole purpose of the brain gauge was to build. 20 years ago, I told the first device that we had was 20 pounds. And I told my colleague, I said, we're going to get this the size of a computer mouse, and we're going to, basically make it low cost. So it'll democratize brain health care. So everyone could track their own brain health and figure out what's going wrong, what makes it work, what makes it better. And so they can, instead of 80% of the potential candidates for Alzheimer's getting it, have maybe 8%. So I think you can have a big impact on healthy aging if you're doing things that promote healthy brain health. I mean, healthy aging in the brain. Um,
Yeah.
it's anyway. That was the whole reason for really doing this and pushing this to over the last 20 years. Because
Yeah.
I thought, if people would just understand and take advantage of the fact that they can do something for their brain health instead of just saying, okay, I'm done. I'm going to retire at 65 and sit down and watch TV for 10 years and then lose my mind and die.
Oh,
So
what a terrible idea. I just
it's
can't think
horrible.
of anything worse.
It's terrible. But
Oh,
I think that's what some people, they're looking so forward to retirement, they retire and then now what, so,
I just can't yeah, I just can't think of anything worse. Okay, so I just have some questions for you.
okay.
Kind of overview. What is the biggest misconception that people have about brain health?
That they're going to lose their brain health when they get older, no matter what, and that there's nothing they can do about it. I'm getting older, therefore my brain's just going to rot.
Yeah,
And
and I
there's
think they
nothing.
lose their motivation to do anything about
Mhm.
it
So
based on
rather
that.
than taking an active stance and saying, I can stay in shape, they just say, no. And these are,
Yeah,
some people just aren't going to be active. They're going to be passive and just say, yeah, I'm going to rest. I worked hard. I'm like, I worked hard my whole life. I'm not going to do anything. Okay, well, you're
yeah,
done. But,
yeah.
you know, I think you want to stay active.
Okay, what is one daily habit that most benefits the brain?
Brain Gauge Gym.
Uh,
Look, I
that
think
makes
exercise,
total
look,
sense.
basically it's more than one. It's fresh air, exercise, good diet, and an active approach to monitoring your brain health. I think those are the most important things.
Brain Gauge Gym absolutely plays into that, and it's
Mhm.
fun.
Yeah, it is.
And that is I mean, that's one of the things too that I think people realize now is, like, it's not just pounding the pavement and pumping iron and, make your body punish your body into submission. It's
Right.
having fun, it's playing, you
Right.
know? Yeah, and the brain gauge makes that really easy.
Yeah.
Um, okay, I wanna know what's the most surprising thing you've learned from decades of studying the brain?
Mm.
This ought to be good.
Okay. I guess the
Don't
most
disappoint me.
surprising thing to me. Okay. So, what I've learned over the years, and this may come as a shock to you, but I learned that teaching people the science behind the brain gauge was not the best way to explain the brain gauge. And so I try to just say, here's what it does for you, and here's what you can do with it. And people then say how or why. And then I start talking a little bit of science, but it's really hard to promote science. And I guess I thought it would be easier, to educate people, but it's okay. It's coming along pretty fast now.
Yeah,
Um, I don't know.
yeah.
And honestly, the most surprising case study, though, which really warms my heart, this was a case study that uh, a guy that works with us, Erskine Thompson, uh, gave a brain gauge to someone who'd had a stroke 3.5 years. And he had just sort of, leveled off and he was shuffling around behind a walker and he couldn't talk so you could understand him. And he went back 34 days later and the guy had been using the brain gauge every day. And he said, he walks in, asked his guy's a friend. He walks in. He said, "Well, how's he doing?" He asked his wife, and the wife said, "Whoa, he's doing fine. He's just doing his normal thing." He walked in. He said, "He doesn't have his walker." He said, "What?" He's like, "He's not even using." Oh, well, it's just been slow. So it was slow and steady, and people don't even notice. It's like after 3 years of using a walker, and now he's not he's talking, so and Erskine could understand him. And I was like, okay, well, that is probably the most surprising case study I've heard to date. And that was and he'd just been using the brain gauge gym and nothing else. And there's a few
Wow.
other stroke stories, but oh my gosh, that was mind
That's
blowing.
amazing.
Yeah. So that's the kind of thing that really kind of is like, okay, we helped somebody. So,
Yeah.
that's good.
That's awesome. So if listeners could remember, if they're going to remember one thing from our discussion today, what do you want it to be?
Parallels between physical fitness and brain fitness are real. Keep in mind, it's not a big mystery. It just cells in the brain, very similar to the rest of your body. Protein synthesis, not that different. So if you exercise the brain the way you exercise your body, you can get it in shape. And that's how you stay mentally fit.
Yeah. Thanks so much, Mark.
Thank you.
The brain gauge represents a shift from guessing about brain health to measuring it. And just as we track blood pressure, blood sugar, heart rate, we're entering an era where objective brain health metrics are becoming a routine part of preventive healthcare, at least in the functional medicine space, and hopefully becoming more mainstream. So if today's conversation has you thinking differently about your brain health, you're not alone. And the exciting thing about Brain Gauge is that it gives us an objective way to measure and track brain function, much like we do the other aspects of our health. And at K6 Wellness Center, we're committed to helping our clients stay proactive, not just reactive, when it comes to cognitive wellness. So whether you're looking to optimize performance, address brain fog, monitor recovery from an injury, or support healthy aging, Brain Gauge can be an important part of your personalized care plan. So thanks again for tuning in. And we really hope that this conversation resonates with you and that you can use this information to make better decisions towards your health and wellness. Don't forget to like and subscribe if you're on YouTube. Follow us on Rumble, Facebook, LinkedIn, and Instagram for more wellness content. And if you'd like to book a consult with one of our practitioners or come try out some Brain Gauge, visit k6wellness.com to learn more or schedule a free discovery call. We're located in Dallas, Texas, but we work with people all over the world. Until next time, take care, be well, and as always, your health is worth fighting for.